Hey everyone, welcome back to another exciting episode where we delve into the fascinating world of welding techniques. Today, I'm breaking down electroslag welding, a process that might sound complex but is incredibly efficient and effective. Electroslag welding, or ESW, is a high-efficiency welding method used primarily for thick metal joints. It's particularly useful in heavy industries where strong, durable welds are essential. Let's dive right in and see how it works. First up, the setup and equipment. Understanding the components involved is crucial for grasping the entire process. The main elements include the welding electrode, the base metal, and copper shoes. The welding electrode is the heart of the process, while the base metal is what you're welding together. The copper shoes play a vital role by holding the molten metal in place, ensuring a clean and controlled weld. These copper shoes are crucial because they hold the molten metal in place, preventing it from spilling out and ensuring that the weld is formed correctly. Picture this: the setup with guiding rails keeping everything aligned. These guiding rails are essential for maintaining the correct position of the components being welded. Simple, right? Now let's talk about arc initiation. This is where the magic begins. The process starts when the electrode touches the base metal, striking an initial arc. The initial arc is crucial as it melts the flux, forming a molten slag pool. This pool is what facilitates the welding process. This arc melts the flux, forming a molten slag pool. The molten slag acts as a shield, protecting the weld from contamination and ensuring a strong bond. It's pretty cool to see the heat waves and glow effects around the molten pool, isn't it? This visual spectacle is a testament to the intense heat and energy involved in the process. On to the welding action. This is where the real work happens. The arc extinguishes as the molten slag takes over. This transition is seamless and ensures that the weld is formed without any interruptions. Here's where it gets interesting. The slag's electrical resistance generates heat, which melts the electrode and the base metal. This heat is what fuses the metals together, creating a strong bond. This creates a strong fusion, solidifying into a robust joint. The result is a weld that is not only strong but also has deep penetration and minimal distortion. As the molten metal solidifies, it forms a strong weld joint with deep penetration and minimal distortion. This is what makes electroslag welding so efficient and reliable. The process ensures that the weld is strong and free from defects, which is crucial in heavy-duty applications. High deposition rate and minimal distortion, that's the goal. Electroslag welding achieves this by maintaining a consistent and controlled welding environment. So where is this technique used? You might be wondering about its practical applications. Well, it's perfect for large structural projects like shipbuilding, bridge construction, and pressure vessels. These projects require strong, durable welds that can withstand significant stress and pressure. It's all about creating strong, defect-free welds with maximum efficiency. Electroslag welding is the go-to method for industries that demand high-quality welds. Thank you for watching. I hope you found this breakdown of electroslag welding informative and engaging. If you found this helpful, stay tuned for more welding processes explained visually. We have a lot more exciting content coming your way. See you next time. Keep welding and stay safe.